This test, ratio test, is always a test for absolute convergence. Unlike the alternating series test where convergence could go either absolutely or conditionally, ratio test is always absolute convergence. And this is used for series that involves factorials and exponentials. So how does this test go? Well, it converges absolutely when the limit as n goes to infinity of the a sub n plus 1 over a sub n. What is this a sub n? This a sub n is your series. If the limit is less than 1, then it converges absolutely. It diverges when the limit is equal to infinity or greater than 1. Okay? It is inconclusive if the limit is equal to 1. When this happens, then you will have to use the other convergence test that we have learned before. So let's look at this problem here. So forming now this limit, the limit as n goes to infinity of e to the n plus 1 divided by n plus 1 factorial divided by e to the n divided by n factorial. We can rewrite this as e to the n. E to the n plus 1 means e to the n times e. N plus 1 factorial means n plus 1 times n factorial. That's by definition of factorial. We recall that n factorial is defined as, here we go, n times n minus 1 times n minus 2 all the way to 3, 2, and 1. So we always begin with n and then we subtract 1 from it until we get to 3, 2, and 1. So looking here, n plus 1 minus 1 will be n. Okay? Divided by, we will now reciprocate this one, n factorial over e to the n. And what do you notice? We can cancel e to the n. We can cancel n factorial. And so this limit becomes e over n plus 1. Now let's find the limit as n goes to infinity. That will obviously be equal to 0. And so because the limit is less than 1, then the series converges absolutely.